Hello dear students, welcome to Toppscholars. Today we'll be discussing about one of the important constituents of air, that is oxygen. Now friends, if I talk about oxygen, what is the symbol of oxygen? Yes, the symbol of oxygen is O, exactly. Now the atomic number of oxygen is 8, right? So its electronic configuration is, yes, 2, 6. Now as you can see over here, oxygen has 6 valence electrons, which means that the valency of oxygen is 2 exactly. Now since the valency of oxygen is 2, oxygen exists as a diatomic molecule, that is O2. So the atomicity of oxygen is 2 exactly. Now friends, this very important constituent of air, that is oxygen, is necessary for the existence of life on earth, which means that plants, animals as well as we human beings, we cannot live without oxygen. So oxygen is necessary for the existence of life on earth. But friends, how was this important constituent of air, that is oxygen, discovered? Scientist named Joseph Priestley was the first to discover oxygen in the year 1774. He obtained a gas on heating mercuric oxide and he named this gas as active air. Later on, a scientist named Anthony Lavoisier in the year 1789 studied the property of this gas and he named this gas as oxygen, which meant acid producer, because oxides of non-metals on reacting with water produced acids. And so Anthony Lavoisier named this gas as oxygen, which is meant as acid producer. But friends, this oxygen, how does it occur in nature? Oxygen occurs in nature in both free state as well as combined state. So in the free state, you will find oxygen present in the atmosphere. So if you look at the composition of air, you will notice that about 78% of air is made up of nitrogen. Air consists of about 21% of oxygen by volume. And if we calculate the mass, oxygen is present in the air. That is, the mass, if you calculate, it comes out to be 23.2%. So, air contains 23.2% of oxygen by mass. Remember, 21% by volume and 23.2% by mass. Whereas the remaining 1% is other gases. So, here we saw that oxygen occurs in the nature in the free state, that is in the atmosphere. But what about combined state? Yes, oxygen occurs in the combined state also. That is, about 89% of water consists of oxygen in the combined state. Also, plants and animals contain oxygen in the combined state. That is, plants contain about 60% of oxygen in the combined state and animals contain about 65% of oxygen in the combined state. Also, oxygen is present in the Earth's crust in the combined state, that is in the form of silicates, oxides as well as carbonates. So what is the percentage of oxygen? 50%. Now friends, we saw that oxygen occurs in nature in the free state as well as in the combined state, right? But can we actually produce or manufacture oxygen in the laboratory? Yes. So let's have a look at the laboratory preparation of oxygen. So now we are going to discuss how do we prepare oxygen in the laboratory by the action of heat on potassium chloride. So let's have a look at the assembly. So as you can see over here I have a test tube. In this test tube, I have taken potassium chloride and manganese dioxide. Now friends, potassium chloride generally decomposes at a temperature of about 700 degrees Celsius. But in the presence of manganese dioxide, potassium chloride decomposes at a much lower temperature, that is about 300 degrees Celsius. And so manganese dioxide here acts as a catalyst. That is, it helps to increase the rate of decomposition of potassium chloride. So in the presence of manganese dioxide, potassium chloride decomposes at a lower temperature, that is at 300 degrees Celsius. Now friends, what we are going to do is, when we heat potassium chloride in the presence of manganese dioxide, potassium chloride decomposes to give potassium chloride along with the liberation of oxygen gas. Now this oxygen gas which is formed passes through the delivery tube. And now as you can see over here, the other end of the delivery tube enters into an inverted gas chamber which is filled with water. And this inverted gas chamber is placed in a trough which is filled with water. Now, as we said, this oxygen gas passes through the delivery tube. This oxygen gas enters into the inverted gas chamber, which is filled with water. You will observe that there are some bubbles formed, right? These bubbles indicate that, yes, there is some gas which is released. And which is this gas? Oxygen gas, exactly. You will notice that as more and more bubbles pass through the gas jar, the level of water in the gas jar goes on decreasing. This is because oxygen gets collected in the gas jar by the downward displacement of water. And so, as more and more oxygen is collected in the gas jar, the level of water in the gas jar goes on decreasing. So, here we saw that potassium chlorate in the presence of manganese dioxide decomposes at a temperature, yes, 300 degrees Celsius, resulting in the formation of potassium chloride along with the liberation of oxygen gas. And we saw that oxygen gas is collected in the gas jar by downward displacement of water, because oxygen is lighter than water, exactly. This is one of the methods by which we can prepare oxygen gas in the laboratory. Let's discuss one more method, right? So, how do we prepare oxygen gas from hydrogen peroxide, right? So, let's have a look at the assembly that we have over here. What I am going to take here is, I have a round bottom flask in which I have taken manganese dioxide, right? Now, as you can see, this round bottom flask is sealed with a 2-bore stopper. Now, through one of the bores, we've passed a thistle funnel and a delivery tube is passed through the other bore. Now, you can observe over here that the other end of the delivery tube enters into a water trough, right? What we have over here, we have a glass jar which is filled with water and we've inverted it on the other end of the delivery tube, right? Now what we're going to do is, we are going to add hydrogen peroxide through the thistle funnel into the round bottom flask containing manganese dioxide. So as soon as hydrogen peroxide comes in contact with manganese dioxide, hydrogen peroxide decomposes into water along with the liberation of oxygen gas. Now friends, the oxygen gas which is liberated enters into the delivery tube. Now this oxygen gas passes through the delivery tube and enters into the gas jar filled with water. Now you can observe here bubbles are formed. These bubbles indicate that yes, some gas is released. And which is the gas? Oxygen gas, exactly. You will also notice that as more and more bubbles pass, the level of water in the gas jar goes on decreasing, right? Which indicates that oxygen gas gets collected in the gas jar by the downward displacement of water. So, as more and more oxygen gas gets collected in the gas jar, the level of water in the gas jar goes on decreasing. So, here we saw that hydrogen peroxide decomposes in the presence of manganese dioxide, which acts as a catalyst, resulting in the formation of water along with the liberation of oxygen gas. And how is this oxygen gas collected? Yes, by the downward displacement of water. Now friends, generally this method, that is preparation of oxygen from hydrogen peroxide, is a very popular method and is widely used for the preparation of oxygen. But generally we do not make use of the potassium chloride method. Why is this so? This is because in this method, no heating is required, whereas in the potassium chloride method, we need to heat at a higher temperature, that is about 300 degrees Celsius. Heating at such high temperature would actually become a risk wherein the glass apparatus can break, which may lead to accidents as well as burns, right? Also, in this method, you will observe that the rate at which oxygen gas is liberated is moderate. And so the reaction is under control. And so this method, that is preparation of oxygen from hydrogen peroxide method, is used for the preparation of oxygen on a wide scale. Now friends, let's move on to the properties, that is physical properties of oxygen. Oxygen is a colorless, odorless and tasteless gas. Is oxygen gas poisonous? No, oxygen gas is a non-poisonous gas. And as we know, all living beings, plants, animals as well as we humans require oxygen for our survival. That is, oxygen supports life. Without oxygen, life would not be there on earth, right? Oxygen gas is slightly heavier than air and that is why oxygen is not collected over air. whereas oxygen is slightly soluble in water. And what is the solubility? 0.7%. We can easily liquefy oxygen, that is, we can convert oxygen gas into a bluish liquid at a temperature of about minus 183 degrees Celsius. That is the boiling point of liquid oxygen. And what is the freezing point? Minus 218.4 degrees Celsius. Remember friend, what is the boiling point of liquid oxygen? Minus 183 degrees Celsius. And what is the freezing point of liquid oxygen? Minus 218.4 degrees Celsius.
To learn more about this topic, download Toppscholars app.